This, hopefully it's showing my entire screen. I have my calculator up here because I think we're gonna have to use it for section 2-3. I just got verbally abused for a little while because they're not excited about applications of equations because it means story problems. So go ahead and shout at your computer screen all sorts of curse words at me because I can't hear you. So there you go. 2-3, applications of equations. Example 1. Woo! Where did we go? We're gone. Where did we go? Oh, there we go. Okay, 2-3, applications. We have, our first example is off over here to the right. And it says the average of two real numbers is 41.125. That's disgusting. And their product is this. Find those two numbers. Okay, now are those two numbers the same number?
No.
No, so we have to have two different names for them. What would you like to name them?
X and Y.
X and Y. Okay, so X is going to be my first number, Y is going to be my second number, and it says the average of those two. Okay, how do I find the average of those two?
Add them up and divide by 2.
X plus Y divided by 2 is 41.125. That's not too bad. And it says, and then their product is 1683. What's that mean?
Multiply.
X times Y is 1683. Okay, now how do I use those things together to find out like the answer?
What you gonna want to do?
Yeah, let's solve one of the equations for one of them and then plug it into the other and like solve that, right? Okay, so which one would you like to solve for?
The
first one. Bottom one.
The top equation or the bottom equation?
Bottom.
The top equation's gonna be nicer. The top equation for what? X or Y, it doesn't matter.
Multiply by 2.
Okay, let's solve for X. So Luke says multiply by 2. Okay, times 2. Times 2, we're gonna multiply that by 2, which makes it a nicer number a little bit. X plus Y will be equal to whatever that is times 2, which is like 82.25. Okay, and then let's solve for, we're still solving for X. So kick the Y to the other side, right? Minus the Y, minus the Y. So X is equal to, how do you want to write that? We can do, yeah, we can do 82.25 minus Y. We can do that. Okay, and then what?
Then plug that in.
Then this junk gets substituted in for X right there, right? So X times Y equals 1683. Whoop. 1683. And this is 82.25 minus Y. Okay, then what?
Distribute the Y through.
Distribute the Y through. Doot, doot, doot. So 82.25Y minus Y squared equals 1683. Ugh. Now what?
Divide by the number.
No, we don't want to do that.
Make it trinomial.
It's a trinomial, right? Okay,
It's not.
it's a trinomial. But the Y squared is negative. I'm going to bump these two to the other side. So I have 0 over here equals. Put them in order. What do you get? Y squared minus 82.25Y plus 1683. Okay. All right, now what? We have some option-y things, I guess, ish. We could multiply to get this and add to get this, except it's going to be a decimal, 82.25.
What if we just do the quadratic?
Do you want to do the quadratic?
Yeah.
Quadratic formula would be easiest.
Yeah, it actually might. Okay. So A is 1. That's not too bad. B is this guy. C is this guy. Okay, so negative B will end up being a positive 82.25 plus minus the square root of 82. I'm going to do just 82.25 squared because it doesn't need to be negative, right? Minus 4 times A times C. That's a lot of stuff. All over 2A, which is 1. Hey, that's not too bad. Okay. All right. Will somebody do the square root of all of this junk together in their calculator? I guess I can do it too. On the square root of
5 3/4.
82.25. You got 5 3/4 squared minus 4. I'm just going to do 4 times the 1683 because it does not, that 1 does not matter. Ah! Oh, did you guys know how to do this? If I missed something and I want to insert something, did you know that you can insert it without it like typing over top of itself? You see this delete key right here? You go second that button and it will insert a parenthesis and it won't type over top of what you're doing. because it's kind of frustrating when it does that, right? Okay, so you said, what'd you say? Now it's not going to calculate it for me. Enter, come on. Oh, it's because we're recording. Haley, you're killing us.
Hubble.
I know, it's all her fault.
5 and 3/4.
Yeah.
There we go.
Under the square root.
Yeah, that's great.
There we go. 5.75 is after you take the square root. 5.75 after you take the square root. So this whole thing is 5.75. Okay, now we have 82.25 plus 5.75 divided by 2 and 82.25 minus 5.75 divided by 2. Alpha, y equals, enter. I don't want that. Clear. Alpha, y equals, enter.
44.
It doesn't like me. I don't know. Anyway, what?
The 44 for
The positive?
dividing by 2. Or, oh wait, I did that wrong.
Do 82.25 plus 5.75 divided by 2,
Yeah, that's
which
44.
is 44. Yes, I agree. Okay, what's the minus? It's going to have decimalage.
I'm having fun.
I got 38.25.
38.25. Yeah?
Yeah.
Yeah. Okay, 44. So that means I have two x's, right? Two x's. So x could either be 44, and if x is 44, then y is something. Okay? I can use either equation, but this one might be easiest. If x is 44, what will y be? 1683 divided by 44 is? I bet you it's 38.25.
38.25.
Hey, okay. And then we got a second answer for x, right? If x is 38.25, y will be 44, right? So no matter what, my two numbers are 44 and 38.25, right? Yeah? I would, if I give you a question like this, and you get that as an answer, and it's like, let's say a test question, I would for certain go back through and make sure the average of those two numbers is 41.125, just to check your answer and make sure it's right? Okay? If I take the average of those two, 41.125, that sounds about right? Okay? That is like one story problem-y thing that we could have, right? Okay, so just like I just got done saying, check your answer at the very end to see if it makes sense, okay? So for this problem, like looking at the averages and stuff, also, I'm going to say no negative lengths. Like you should not have a negative as an answer for a length, because sometimes when we do the quadratic, you will end up with a positive and a negative, but if it's in a story problem, you'll only end up using the positive number, right? Because a negative, you can't have a negative length. What?
Yes, you can.
Even if you're going backwards. I
No,
don't care. What?
But it's all about your perspective.
No,
and
we're not going back in
your
time.
vector.
No,
It's
not
all
a thing.
about the vector.
No. That has to do with direction, and no.
Yeah, direction and negative.
Direction
If you're
are
going in
story
the opposite
problems.
direction, it is
No.
negative.
No. We will end up doing vectors in this class, though.
Are you kidding me?
Yeah.
You could just say negative
Chapter 10,
36
okay?
degrees north of west.
Okay. The second thing, make sure it satisfies the given conditions. Okay, so like I said, plug back in and make sure that it makes sense. And then does it answer the original question? So those things are things that you might want to check off in your head and that type of thing. Okay. Example 2. Here we go. A rectangle is twice as wide as it is high. They will give that as a preface to the story problem. And you have to draw a picture and figure out what that looks like. So they have a rectangle and it's twice as wide as it is high. So they said h is going to be the height dimension, right? And then the width we're going to represent as twice the height, right? So width is going to be 2h. So we have h and 2h. Quit it. H and 2h, okay? All right. If it has an area of 24.5 square inches, what are its dimensions? All right, so the width is twice as high. How do you find the area of this rectangle? Base times height, right? So 2h times h, the base times the height, right? 2h times h. And we want that to be equal to 24.5. This one's going to be a nice, easy one, okay? That equals 24.5. Okay, now what?
Divide half of
This is, hold on, what's 2h times h?
H squared.
2h squared equals 24.5. Now what?
By 2.
Divide by 2.
12.25.
12.25. H squared equals 12.25. Okay? Take the square root. What's the square root of...
3.5.
Is it 3.5?
Yeah.
Okay, now, technically, we put the square root in there, so it is plus and minus 3.5, but this is where I'm saying, go back and look. Does it make sense to have a negative length for your height? Or negative value for your height? So in that case, it is just the positive 3.5, and this is in inches. Yes, square inches, so this is in inches, right? If 3.5 is the height, what will the width be? 7, double that, right? 7 inches. There you go. That one was not too bad, right? Coming up with this like diagram or like drawing that picture is probably going to be the hardest thing. So just take that first sentence, figure out what your variables are, like height. Double the height means 2 times the height. Okay, you can use x if you want to, and then this would be 2x. I don't care. Doesn't matter what your variable's called, but setting that up to begin with is going to be the hardest part, and then it's really easy to solve from there, right? Okay. Example 3 is volume. Okay. This one's going to be a little bit harder. It says a rectangular box with a square base. Circle that because that's really important information when they give you that. A square base and no top is to have a volume of 30,000. Okay? If the surface area of the box is 6,000, what are the dimensions of the box? So we have a volume and we have a surface area. Okay. So the volume of a thing is the area of the base times the height. Capital B times H. Capital B means the area of the base, okay? Surface area is the area of all of the surfaces added together. So we're going to figure out what that is, okay? Over here, they've drawn a picture of this, and the square base thing is like hugely important because we go from having 3 variables, like an x, a y, and a z, to only 2 because we know that this is the same as this, right? Does that make sense? If it's a square base. So we go from having 3 variables to only 2. They represent this as S for the side, right? S and S, and then H is the height, yeah? Okay, so if I'm trying to find the volume of this thing, it's the area of the base times the height. What would the area of this bottom part be? S squared. S times S is S squared times the height is that guy. This is the volume. Now, does it matter that it doesn't have a lid on it for volume? If it doesn't have a lid, it's going to hold the same amount of water. It's just not going to be capped off at the top, so it doesn't matter, right? Volume is like how much water it can hold. So S squared times height, we want that to be equal to 30,000. Yeah?
You also have to include the surface tension in the water, which would...
No, we don't care. We don't care. Get out of here. This is our equation, okay, for volume. Now we have to talk about surface area. So the area of all the surfaces. I'm going to do my scratch work over here for surface area. Okay, so we have a bottom surface. What's the area of the bottom surface?
Length times width.
Length times width, which is this times this, which is S squared. Now we normally would have a bottom and a top, right? So I would have 2 of those. But we only have 1 because we don't have a top, right? So this is the bottom. Bottom. Okay? Now we have the side. So like let's look at this front side. This is another rectangle and it's a what by what? S by H. So the area of that thing would be SH, right? Yeah, but there's 4 of them around the edge, so 4SH, okay? So I should have altogether how many surfaces?
5.
5, because there's no top, right? I have 1, and then 4 of those, so that's 5, right? So what's the surface area going to look like?
4 times
S squared plus 4SH, or the other way around, it doesn't matter, right? We want that to be equal to, how much? Okay, all right. Now we've got our 2 equations. So just like example 1, we've got to find a way of like putting them together, right? Okay, so we have to solve one of the equations for one of the variables. Which one would you like to solve for? There's one that's easier than the others.
We should solve for H.
On which one? Which H?
The bottom.
Top H or bottom H?
Bottom H.
Top X.
Let's do top H. Top H. Top H. This H right here. If we do that, we're going to divide by S squared. So H equals 30,000 divided by S squared, yeah? Okay, now let's plug that in here. Woo. All right, so we've got S squared plus 4S times 30,000. We're going to simplify here in a second. Over s squared equals 6,000. It's really gross. It's really super gross. We'll be okay. What?
You give us a problem with this?
Maybe one.
Oh
Maybe one. I don't remember.
Well, it's not that bad. Really?
No, I do a two-dimensional one to you though.
Dude.
The homework problems are actually fairly short and sweet. Okay. All right, so s squared, this guy just stays s squared, right? Okay. This s can cancel with one of these. Did you know that? And then 4 I can take times this 3,000 or 30,000, which is
1,200,000.
120,000 over s equals, and I'm going to move the 6,000 to the other side. Minus 6,000 equals 0. Equals 0. Okay. Now what do we do?
Thing we got going on here. Okay. Can you? You can just take 12,000 divided by 6,000. Why didn't you just do that?
What do you mean?
So in the top equation, why didn't you just multiply the s over, divide the 6, then you would have a number.
You can't divide the 6.
Yeah, you can.
Where?
You multiplied the 6,000. So you multiplied the s over on the s squared plus 4. Or no. Wait, just okay. It's hard to speak. Okay, so you have the 6,000 is positive on the other side.
Mhm.
Okay, you multiply that by s, and you cancel out the s on the other side, and then you have s to the third.
Oh, I like this idea. That's what we're going to do next. That's what we're
And
going to do
then
next.
you-
Okay?
You
Now, we could technically leave this the way that it is right now, right? I have 3 pieces. I have 1, 2, 3, right? Okay? And we hate fractions, right? We hate fractions. I don't like that s on the bottom. So, this is what Luke is saying. He says, okay, we could technically leave it like this and plug it into our calculator and do whatever, right? But there's one thing I'm going to do first, and it's what Luke's talking about. Let's multiply everything by s, right? Okay? So, let's show you what happens.
wait.
If I take s squared times s,
That gives you
s
s to the
to the third, what happens if I take that stuff times s?
just 12,000.
It's just 120,000, right? If I take 6,000 times s, minus 6,000 s, and if I take 0 times s, which you still do, right? You still have to take 0 times s, it's just going to stay 0, right? Okay, now what do I do? This looks like a quadratic, but it's not because it's s to the third power. I have no s squared variable, right? So how do I find this?
If we plug it in the quadratic function, I will walk away.
No, it won't because it's not a quadratic.
No, I don't know where we got
We
the S.
should
Where did we get that S?
Divide by
This,
12.
we're just trying to get rid of this s in the bottom so we can multiply everything through by s to get it to go away in the bottom. It's like if you were dividing by 4, you could multiply everything by 4 to get rid of the fourth, right? Okay? So it's just getting rid of the fractiony things. So now what do we do?
Plug it into our solver problem.
There
Nah,
you go.
nah.
Nice. Thank you, Miss Brainium.
Nah, we're gonna plug it into our calculator. I don't want to solve this thing, so I'm gonna go to y equals, and I'm gonna make it so I'm gonna graph the thing, and I'm gonna make it solve it for me. So x to the third, and it doesn't matter that these are not in order. I could do 120,000 next. 1, 2, 3, minus 6,000 x. Okay, and I'm gonna make sure my window is negative 10 to 10, which it is, and I'm gonna graph. Yikes. It's nowhere to be found. Oh, wait. It is. It's really skinny in there. Do you see it?
Too big of a thing.
I have too big of a thing. So we got to narrow them down. Let's go window. I'm going to go like negative 1 to 1 on the x.
No.
I don't know.
Maybe the solver is unreliable.
Ah, there it is.
No.
There it is.
How do you plug on your calculator? How do you put equal 0?
This is an s to the third power, though.
It is already equal to 0.
Yes.
Yeah.
Why 1 is 0?
I'm going to go window. Hold on. Just bear with me. Don't do this yet.
James.
No, I'm going to go 5,000 for x. I'm going to go negative 100. Don't do this. Don't do this. I just want to see if it'll work. Don't do it.
No.
Wait, what'd You can figure
That's
max
good.
X.
It's
So
clear.
that's
We
why.
can do that.
Puzzling.
Don't crumple it. Jason.
Puzzling.
That was a work of art.
That was beautiful.
Would you use the Mona Lisa as a like?
It's not our plane.
That was.
No, she already crumbled up the plate that you made. I'm not making another.
Okay, we're gonna go back to my original.
Oh, wait.
This guy right here.
I found it on the outside.
We're almost done. Did you find him?
Yeah.
Did you find the S?
What's that?
I did -1 on the X, and I left -10 to 10. We want, since this is a story problem, we have 2 places where it's crossing, but
What in the world?
I don't care about this one because it's negative. It's going to be a -S, and we're talking about side length, so I just want this one. I'm going to zoom in on plus 120,000. There we go. Now my window's going to be off. Okay. Okay, hold on.
My calculator shows it means it's 5.
Grades 9 through 11, please stop by the office to vote for homecoming candidates. Also, a reminder that junior high boys and junior high girls locker
Puzzling.
rooms are going to need to be cleared out.
I can't zoom out far enough.
We gotta clean up. We got 1 minute till the bell rings. Shucks.
It's 12 1/4.
Shucks.
It's what?
12 1/4. You plug it into your solver thing. That Booth showed us.
What?
Keep talking about what she does.
Well, she can have it, Charlotte.
But my, I don't know. Okay, stop here. We'll graph him on whatever day it is. Wednesday. Monday. No, Wednesday.
No, Monday.
Can I have my homework?
120,000.
Didn't get me. Zach, can we have our homework?
Can we get our homework?
Can we get our home?
Please.
Hey, some of us will be here.
Yeah, for just
Some of us will be here to go to the damn flag football on the weekend. Whoa.
Yeah.
I promise
Yeah.
I will
We're
be
playing
there.
either flag football or ultimate football. FYI, you need to already know. Sorry, the first one.
Hey, there it is. There's the other one. Oh, there's 2 of them. Hey, I went -100 to 100. Okay, I'm going to save that in there. All right. Okay, bye, Haley.